Light. A form of energy that gives the sensation of sight is called light. It is a form of energy. Observe a beam of light entering your room through the window or light coming through the bulb of a torch. They all are seen moving in straight line. Rectilinear propagation of light. The beam of light is seen as straight lines. This is called rectilinear propagation of light. This means that light can travel only in a straight line. We can see a light source only if a straight line path is available from the source up to our eyes. If the path is bent anywhere, we will not see the source of light. Reflection of light. When a ray of light, while travels from one optical medium to another optical medium, say from air to glass, these situations can arise. The ray of light may be returned by the second optical medium into the first optical medium with a change in angle. This phenomenon is called reflection of light. The ray of light may get absorbed by the medium. The ray may pass through the second optical medium with a change in angle. This phenomenon is called refraction of light. It may be pointed out that all these phenomena can take place at the same time. It means a part of light energy can get reflected, a part absorbed, and a part refracted. Reflection is that phenomenon which causes the formation of images. There are a few basic requirements for reflection to take place. They are a source of light, a shiny surface from which reflection can take place. The rays that originate from the source of light are said to be incident rays, and the rays reflected off the surface are called reflected rays. The image is formed at the same distance from the mirror as the object is kept in front of it. The image formed by a plane mirror cannot be obtained on a screen. All luminous objects, both natural and artificial, are called sources of light. While the sun and the stars are the natural sources of light, an electric bulb or tube light is the artificial source of light. The light emitted by these sources travels in straight line. A narrow path of light presented by a straight line is called the ray of light. A thick ray of light is called a beam of light. It can be classified as parallel beam of light. A beam of light where all the light rays are parallel to each other is called a parallel beam of light. Convergent beam of light. A beam of light which comes from a broad source of light and converge at a point is called convergent beam of light. Divergent beam of light. A beam of light which comes from a small source and diverge out is called a divergent beam of light. Types of image. An image of an object can be real, virtual, erect, or inverted. Let us discuss about the various types of image. Real image. An image that is formed on the screen is said to be real image. It is formed when the light rays actually meet after reflection. An image formed by a projector in the cinema hall on the screen is an example of real image. Virtual image. An image that appears to be formed behind the mirror is said to be virtual image. Such an image moves towards or away from the mirror if the position of the object is changed. It cannot be obtained on the screen. For example, image formed by plane mirror. Erect image. An image is said to be erect if the image is exactly similar and upright as the object. Inverted image. An image that is not upright is inverted. Lateral inversion. Have you ever observed yourself in the mirror? Your left hand appears to be right hand and right hand appears to be left. Have you seen the word ambulance written on the car? It is written as, but the same word appears as ambulance on the mirror of the one driving in front of it. This shifting of right hand as left and vice versa is said to be lateral inversion. To sum up, The characteristics of an image formed by a plane mirror are: the image is virtual. It is erect. It is of the same size as the object. It appears to be as much behind the mirror as it is in front of it. It is laterally inverted. Uses of plane mirrors. Plane mirrors are extensively used in our daily life. Some of their important uses are: they are used as looking glasses. They are used as reflectors in solar cookers. They are used in making kaleidoscopes and periscopes. To give false dimensions to shops and departmental stores. Spherical mirrors. Any reflecting surface which is the part of a sphere is said to be a spherical mirror. The nature of images formed by spherical mirrors is different from that formed by plane mirrors. The reflecting surface of a spherical mirror can either be outside or the inside of the curved surface, depending on the silvered side. Spherical mirrors can be of two types: concave mirror and convex mirror. If the reflecting surface is inside, then such a mirror is called a concave mirror. If the reflecting surface is outside, it is called the convex mirror. Some terms related to spherical mirror. Pole. The geometrical center of the spherical mirror is called its pole. Center of curvature. The center of the sphere, of which the spherical mirror forms a part, is called the center of curvature. Radius of curvature. The line joining the pole and the center of curvature is the radius of curvature. Principal axis. An imaginary line passing through the pole and center of curvature is known as the principal axis. Uses of convex mirror. It is used as a rear-view mirror in vehicles because it forms an erect and highly diminished image, irrespective of the position of traffic behind. It is used as a reflector in street lamps. It is used as a vigilance mirror in departmental stores. Uses of concave mirror. It is used as a shaving mirror and as doctor's head mirror. It is used as reflector in projectors, lighthouses, and car headlights. It is used in floodlights. Lenses. A lens is a transparent medium with two curved surfaces. A lens may be concave, convex, or a combination of various types of lens. A convex lens converges the rays of light at a point and is called a converging lens, whereas a concave lens appears to diverge rays of light from a point and is called a diverging lens. Based on their converging and diverging abilities, lenses are extensively used in spectacles. In the first case, the spot formed on the paper is actually the image of the sun formed on the screen by the lens. Therefore, it is a real image. This point is called the principal focus, F, of the lens. A converging lens bends a ray of light passing through it inwards towards the principal axis. It makes all rays parallel to the principal axis converge to a single point, called the principal focus of the lens. In the second case, no bright spot is seen on the paper because concave lens has the property of bending a ray of light passing through it outwards. The light ray parallel to the principal axis spreads outwards away from the principal axis, diverge, and appear as if they were coming from a point. This point of convergence from where the rays of light appear to come after passing through the lens is the principal focus of the concave lens. The distance between the optical center O and the focus of the lens is called the focal length of the lens. Here is an activity to show that the image is formed by a convex lens. Take a convex lens and fix it on a stand. Place it on a table and place a lighted candle at a distance of about 50 cm from the lens as shown here. Also, place a white screen on the table on the other side of the lens. Adjust the distance of the screen from the lens to get the image of the candle flame on the screen. Try to obtain the image of the candle on the paper screen on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. Now, alter the distance of the candle from the lens. Try to obtain the image of the candle flame every time on the paper while altering the distance and record your observations. The conclusions of this activity can be summarized as: when the object is far away from the lens, the image formed is real and inverted. As the object is brought closer to the lens, it becomes bigger and moves further away from the lens. When the object is very close to the lens, the image can no longer be formed on the screen. Now repeat this activity with a concave lens. You will find that for all distances of the object from the lens, a concave lens forms an erect, diminished, and virtual image of the object on the same side of the lens as the object. Convex lens, concave lens. It is thicker in the middle and thinner at edges. It is thicker at the edges and thinner in the middle. When the lens is held close to the object, it forms a virtual, erect, and magnified image. When the lens is held close to the object, it forms a virtual, erect, and diminished image. When the lens is held away from the object, it forms a real and inverted image. The image may be magnified or diminished depending upon the distance of the object from the lens. When the lens is held away from the object, it forms a virtual, erect, and diminished image for all positions of the object. Used to correct long-sightedness or myopia. Used to correct short-sightedness or hypermetropia. White light. All of us enjoy the sight of a rainbow. A rainbow is a band of 7 colors with violet, indigo, blue, green, yellow, orange, and red. When white light falls on a prism, it splits into a band of 7 colors. These are the colors of the rainbow. Sir Isaac Newton performed an experiment and named these screen colors as spectrum. The phenomenon of breaking off white light into a band of 7 colors is called dispersion. Rainbow also occurs due to the phenomenon of dispersion. The droplets of rainwater act as a prism.